Okay. Okay. This week we continue with our last topic of our semester. This is a nonlinear operation of op-amp. Okay. Before we start, just want to make a revision. What is different between linear operation and nonlinear operation of op-amp. Okay. In the last week we have discussed on the linear operation. So linear operation is basically it is an amplifier. Okay, so when you use the op-amp as a linear operation, so your target is you want to amplify the something, or you want to have the mathematical operation. Okay, so this is your target. Okay, but for the nonlinear operation, so the nonlinear operation is more on the switching. Okay, switching, and then based on the switching, it can be used as a comparator. Okay. Okay, and then this is the in term of the application of the usage of the linear operation and nonlinear operation. Okay, for in term of the circuit itself, the linear operation, all of the circuit in the linear operation will have a negative feedback. Okay, so what is negative feedback? Negative feedback is, as we have discussed before, the op-amp, this is the symbol of op-amp. It has two input. So one of the input is non-inverting input, which is plus, V plus, and another input is a inverting input, V minus. So this is the two inputs, and then we have here we have the output. The negative feedback is the connection between the output. Yeah, this is your V out. Connection between your output with the inverting input. So this is your RF, the feedback resistance. So this is what we call a negative feedback. So why negative feedback is important? Because negative feedback will reduce the gain. Reduce the open loop gain. Okay, so the ideal op-amp have a infinite open loop gain. So in ideal op-amp, the open loop gain is infinity. If the open loop gain is infinity, so it is quite difficult to use the op-amp as an amplifier because the gain is too much. So we need to reduce the gain to the certain level that is usable. So that's why we apply a negative feedback. Okay. So by having negative feedback, you can control this is one point, reduce, and then you can control the gain. Okay. So that let's say this is your V in, and this is the ground, so that your V in and V out will have a relationship of V out equal to A V in. So this is a not infinite. This is will have a certain device as certain value. The gain will have a certain value. So this equation is a linear equation. So this is a linear operation. Okay, so this is what we have discussed in the previous week, which is a linear operation. So the A is the gain for the linear operation is not the infinite gain. It is it has a value, the moderate value. and then the gain can be controlled by changing the value of the resistance in the circuit. Okay. So this is the linear operation. Okay, so next we go to the nonlinear operation. So nonlinear operation will not have it's not a negative feedback. It has two types. The first type is the open loop type. Okay, and then it can also have the positive feedback. Okay, so let's discuss the open loop uh, setup or open loop configuration. So this is you consider the op-amp. Okay, and then let's say this is your input and this is output. Okay, for the nonlinear operation, usually we have the two input value. Okay, for the nonlinear operation, for the linear operation, sometimes we have one input V in, sometimes you have two inputs, or sometimes you have more than two inputs. Okay, for example, in the summing amplifier, you can have more than one input value. Okay, but for the amplifier, for inverting amplifier, you only have one input. For example, this is inverting amplifier, so you only have one input. For the nonlinear operation, usually we use the two input. So one of the input will be at the V plus. So this is your input V plus, and this is your another input V minus. And then you have the V out here. Okay, for this setup, the open loop gain is infinity. So we start with this general equation for the differential amplifier. So V out is equal to A. This is V plus minus V minus. Okay, so V plus equal to A, V plus minus V minus. V out equal to A, V plus minus V minus. Okay, so if A is infinity, so what happened to the V out? So what happened to the V out? Okay, so V out will become plus infinity. Okay, if the V plus minus V minus is positive. Okay, if V plus minus V minus is positive, if this value is positive, so V out will become positive infinity. Okay, if V plus minus V minus is a negative value, so what happened to the V out? This is a negative infinity. Okay. However, so we have discussed the in the actual op-amp, there is a supply DC voltage plus VCC and negative VCC. Okay, we have here the plus VCC and we have a negative VCC. Okay. The common rule is the output of the electronic device cannot produce higher higher voltage value than the supply voltage. Okay, than the supply voltage. This is common rule. So what happened means that the output voltage here will be limited by the plus VCC and negative VCC. So although in terms of equation, V out is equal to plus infinity, but in actual operation, V out will equal to the maximum positive value is plus VCC. Okay, for the case of V out is equal to negative infinity, so it will limited by negative VCC. Okay, so now you have the equation for V out here. So V out is either positive VCC or negative VCC. Okay. So in this case, this is not a linear equation. This is just a digital equation, a digital function. So if you consider the plus VCC as your as your one state and negative VCC as your zero state, so this is a digital application. So that's why it is considered as a switch. The nonlinear operation can be considered as a switch. Okay, so this is the nonlinear operation. Okay, so this slide describe again what I have discussed just now. So we just repeat it again. So this is the symbol of op-amp. For nonlinear application, usually we utilize both of the input, inverting input and non-inverting input. Okay, inverting input and non-inverting input, and the output can be expressed as equal to A V plus minus V minus. So V plus minus V minus is the input. Okay, is the input of the op-amp, and A is the gain. A is the gain. Okay, since A is infinity, the ideal op-amp is infinity. So what happened to the V out will become maximum. So V out is also infinity. Okay, V out is infinity, but you need to decide whether it is positive infinity or negative infinity. Okay, so how we decide the polarity is based on the V plus minus V minus. Okay, if this is the transfer characteristic of the op-amp, so this is V out versus V in input. The input of the comparator is V plus minus V minus. If V plus minus V minus is positive, the V out will become positive infinity. If V plus minus V minus is negative, V out will become negative infinity. However, you see here this one, the output voltage is not infinity. It is limited by the supply, by the maximum allowable output voltage. So in this slide, it is denoted as the Vmax. So plus Vmax and negative Vmax. So we'll have a limited maximum voltage and limited minimum voltage. Okay, so that's why this transfer characteristics become like this. So at certain point, it is fixed at the plus Vmax and fixed at the minus Vmax. Okay. Okay, take a look at this statement. So in this positive input region where the V plus minus V minus is larger than 0, so it means that okay, this is where the V plus is larger than V minus. Okay, when V plus larger than V minus, so V out will equal to plus VO saturation. VO saturation is plus V max. Okay, and then in this region, okay, in this region, this is where the V plus minus V minus is negative or lesser than 0. So means that V minus is larger than V plus. So another way around. So what happened? The V out will become negative V max. These two statements so describe the operation of op-amp as a comparator. So this is one of the explanation or procedure or operation of the comparator. So the comparator compare between this V plus, the input of V plus and the input of V minus. So it compare the V plus and V minus, and then the output value will depend whether which one is bigger. If V plus is bigger than V minus, the output will give you the positive VCC. If the V plus is lower than the V minus, so V out will give you negative infinity. So this is the comparator. Okay, so this slide show the practical transfer characteristic. So the difference between the this slide with the previous slide is for the practical characteristic, the open loop gain is not infinity. Okay, the A open loop, the ideal is infinity, but in the practical, it's not infinity, but it's quite large. It is larger than 10,000 times. So instead of drawing the vertical line here, so we can draw a line with the is a quite steep slope here. So draw the line, and you need to be aware that where does the positive voltage saturate. Okay, so in the previous slide I have explained that the positive output voltage is saturated or fixed at the plus VCC, but in the actual op-amp, the positive maximum voltage output voltage is slightly below than plus VCC. So slightly below than plus VCC. So in practice, the output saturation usually 1 or 2 volt less than plus VCC. Okay, if you supply 12 volt as your VCC, so your saturation voltage is around 11 volt to 10 volt. Okay, so this is the practical characteristic. Okay, so but for this subject, so you no need to consider this plus or 2 minus less to plus 1 or 2 volt less. So it is depend on your question. If the question just give you the plus VCC, so you use the plus VCC as your maximum value. Okay, if the question give you the V out saturation value, so you use that value as your maximum value. Okay, so this is the operation of example application of comparator. So if you have this op-amp, okay, and then you want to detect this peak. Okay, you want to detect this peak. So what you can do is you supply this biological signal. So this is your ECG, the cardio related signal, as your V plus, and then at the V reference or V minus, you supply the voltage at this level. So what happened? Is the V reference and the V out will become plus VCC only if you can detect the signal that is larger than V reference. If the signal at the V in is larger than V reference, you will get the pulse at the output plus VCC. So this is where the V in is larger than V reference, or V in is a V plus is larger than V minus. So this is how you can use the op-amp comparator in the actual application. So we compare the V plus and V minus.